we really talk about those same vocab words that we talked about at the very beginning. Vertex, max and min, roots, axis of symmetry, y-intercepts. Really important that you guys know what those are. So we're going to label the following. I'm just going to go with each one. The vertex is going to be the tip where it changes direction. Label those on both graphs. Vertex. All right, we've done that. Our axis of symmetry. Axis of symmetry goes right through the vertex. And it is a vertical line. It's always going to be x equals something. And it is tied to your vertex x coordinate. It splits the parabola into two halves. Max and min is determined by the vertex. If it's at the bottom, it's a min. So this is a min. If it's at the top, the vertex is at the top, it's a max. Y-intercept means exactly what it's meant all year. It's where it crosses the y-axis. So y-intercept is actually the vertex on the first graph. And the y-intercept on the second one is right here. Finally, the roots. What are the roots? Can I remember? Another name for roots is zeros. Yep, it's where it crosses the x-axis. So right here and right here are roots. Right here and right here are roots. You might see those called zeros, solutions, x-intercepts, or roots. Okay. Now on the bottom, we're going to use our calculator. Let's go ahead and put this equation in y equals, bless you, exactly how it's there. 2 parentheses, x minus 1 parentheses squared minus 2 and graph it. Okay, so looking at the graph is really just going to give us a hint on if it's a min or max. We can tell from the graph. It definitely is a min. And there are two roots. There are 2 zeros because it goes through the x-axis twice. We always know domain is all real numbers, so you can put that on both of them. Okay. All right, so for the rest of this, we need to head on over to the table. So go to the table on your calculator. And what is it I tell y'all to look for when you're trying to find the vertex? The sandwich. Yep, look, I found it. 0, -2, 0. So your vertex is 1, -2. 1, -2. Your axis of symmetry is always tied to your x value from your vertex. It's 1. X equals 1. The y-intercept is always where x equals 0. So where x equals 0, it's 0, 0. It's y-intercept, 0, 0. It's not y equals. It's just 0, 0 from the table. We know there's 2 roots. What are the solutions? Okay, so they want to know the points that it crosses the 2 zeros. So y is 0. So 0, 0 and 2, 0. It's just where x equals 0. The range is always connected to the y in your vertex. So since this one is going up, it's going to be y is greater than or equal to -2, because that's what our vertex is. All right. Let's do the second one. Go ahead and put that in your calculator. Y equals negative, parentheses, x plus 3, parentheses, squared. All right. So we can see that this one's going to be a max. The vertex is going to be at the top. It's also going down, so we know the range is going to be y is less than or equal to. And it looks like there's only 1 0, but we'll be able to tell that for sure on our table. So I'm heading over to the table. Looking for my vertex sandwich. We have a negative 1, 0, negative 1. So it looks like my vertex is negative 3, 0. Axis of symmetry, it deals with your x value of your vertex, that's negative 3. And the y-intercept is where x equals 0. Look at your table, it's negative 9. 0, negative 9. Says, what are the roots? The roots are where there's a 0. There's only one, and it's negative 3, 0. Okay, so please be familiar with how to fill out that chart, just like your quiz, which I still have almost finished grading those. Huh? Didn't finish what? Oh, yeah, you're right. Greater than or equal to 0. It goes with the y value in your vertex. I mean, less than or equal to 0. My bad. Sorry. Good point. Okay. Number 4, the graph below represents the height of the rocket that's launched from the top of a platform, I'm guessing. All right, so I'm going to just kind of make a note here. We have to see what are, when you first look at a graph, you always should train yourself to think, what are the values of each of the lines? Because on the STAR test, they are never just one, hardly ever, okay? So you kind of have to look at the rest of them and see, oh, these are two, each line is 2 meters apart, okay? On the seconds, down here, each line is 0.25, okay? So this is 30 feet. Which statement best describes the path of the rocket? The rocket reached the ground between 2.25 seconds and 2.5 seconds. Okay, so we have to go through each of these individually. Well, it doesn't reach, this is 2.25. So it doesn't fall in that category. Nope. It would have to go in here, and it reached the ground before that. The rocket was below 34 feet from 0.25 seconds and 1 second. So this is 0.25 and 1. This range right here. Was it below 34 feet? Nope. It was higher than that. The rocket reached its maximum between 1 second and 1.25 seconds. This is the range there. No. Hopefully it's D. The rocket descended 8 feet between 1.5 seconds and 1.75 seconds. So from here to here, it went from 24 to 16. That is true. D. 24 to 16 equals 8. All right, number 5. What's the vertex of the graph? See if you can figure that out. The coordinate point. You got to figure out what each line is first. This is dumb because it's going by thirds. So the x is definitely negative 1 and 1/3. So which one is that? Yep. B. So you really have to watch those grid lines. All right. Which statement best describes the graph below? The ball was dropped from a height of 18 feet. This is 18. Going by ones. And then reached a maximum height of 20 feet. No, it never went higher. The ball was thrown from the ground. Nope, was not thrown from the ground because it was thrown from 18 feet. The ball was dropped from a height of 18 feet, yes, and descended for just under 2 seconds before it hit the ground. Yes, just under 2 seconds. Maybe. The ball was thrown from a height of 2 feet. Nope, so it's C. Number 7, the graph below shows the height of a ball versus time for one bounce. How many seconds was the ball at a height of 7 feet or more above the ground? Okay, so look, you have to go over here to 7 feet or more. So from here to here. All right, this point to this point. Oh, actually, from this point to this point. Because from 0.25 all the way to 1.75. So how many seconds of time is that? 1.5 seconds. Not just the vertex, because it's still above 7 over here. All this is still above 7. So from here to here is when it went under, it was above 7. That's 1.5 seconds. All right, number 8. You can see it's good that we did lesson yesterday because there's a lot of questions with a graph and reading these parabolas. The domain and range of this graph. What's domain always going to be? All real numbers. Range, you have to look at the vertex, and it's your y value in your vertex. So 30, and it's going down. The parabola is going down, so it's less than or equal to 30. Yep. Because it has to be a point on the line, so that makes it equal to. Number 9, Derek launched a model rocket as shown in the graph below. How many seconds will it take for the rocket to be at the same height as when it was launched? Okay, so it was launched at 80. When we're looking to see when it gets back to 80. So that's at 2.5 seconds. How many seconds was the rocket at 80 feet in the air? Okay, so from here to here, pretty sure we just answered that. 2.5 seconds. How long was the flight? Yeah, a little over 3.75. So it's about 3.8, yeah. Yeah. It was about 3.8 seconds. It was a little over 3.75. So about 3.8. How long did it take for the rocket to reach its maximum height? Right here is the maximum. 1.25 seconds. Did the rocket spend more time ascending or descending? Yep, descending. All right, number 10. First of all, we have to figure out what's the quadratic parent function. It's written on the graph right here. Y equals x squared. That's the graph that we use to base all of our transformations off of. So speaking of transformations, we're going to describe each transformation below when compared to x squared. All right, so x squared, we don't have to draw this on every one of them, but I just want to show you. Looks like this. Okay. It's this graph up here at the top. So what did it do? It moved up how many on this one? Plus 3. So it's x squared plus 3. Down here, it looks like it's reflected from the x-axis. So what did that mean it happened? What happened to the x squared? No, what negative? Good. Again, this is using that cheat sheet from the back of the notes. If you need to, you can. This right here. Yes, we can. I'll let you use your notes on the test. Match the following functions. Number 12. So when we have a 4 multiplied by it, it's greater than 1. It means it's going to be super narrow. And then it's going to move down 3. So which one is moved down 3 and it's really narrow? E. Yes. So this one's multiplied by a fraction. So a fraction is going to make it fatten. It's going to be wide. And then it goes up 5. Yes, D. All right, we have a negative, so that's a reflection, and a fraction. So it's going to go wide and reflect. Which one is that? A. We have another reflection here because it's negative, and it's 8, so it's going to be real narrow. B. And then finally, this one has to be C, but it's okay. So this one's tricky. It's a reflection of a negative. So it started out down here, and when it reflected again, it made it positive. So you have 2 negatives made a positive, and it's narrow because 5 divided by 2 is more than, it's 2.5, which is more than 1. So C. Okay, number 17. We're going to skip 17. There's not one like that on the test. Look at 18. 18 is very much like what we did yesterday, so I'm going to say see your notes packet. In fact, I think it's the same one. Y'all remember this one we did in the notes yesterday about the golf ball on the moon? See notes packet. Okay, so we're going to skip 18. I know you're so sad. We're on the last page. Look at that. Number 19. For precisely which values of the constant does the graph of y equals x squared plus c contain 2 x-intercepts? So what it's saying is which graph is going to give you, which graph's going to make it cross the x-axis twice? Okay, at 2 points. Is it going to be any positive integer? Oh, the c. We're looking at what's added to it. So for it to cross twice, that means it has to go down from the parent function. It has to go down so that it can cross twice. So what does that c have to be? Does it have to be positive or negative? It has to be negative. A fraction doesn't matter if it's positive, and the number 0 is not going to do anything. It's just going to stay the same. It has to be negative to make it go down. Because if it went up, it's not going to cross the x-axis twice. That would be positive. This is negative. It would go down. And it's going to cross 1, 2. Number 20, the quadratic equation y equals x squared plus bx plus c. Which of the following will cause the graph to reflect over the x-axis? Reflect. Or actually here it says reflect. Which term has to be negative? This is an a right here in front of the x squared. The a, the b, or the c. Which one needs to be less than 0 to make it reflect? The a. The a has to be less than 0. Bless you. B. It can't be option A because that says 0 is less than A is less than 1. No, it can't be between 0 and 1. That's it. That's a fraction. That's just going to make it wide. Number 21, what's the reasonable domain and range for the equation y equals 1,000 minus x squared? So I'm just going to put that in my calculator because if all else fails, that's what you could do. 10,000, my bad. 10,000 minus x squared. Ugh. Oh, it's definitely not going to show. Zoom. I keep having to zoom out because it's at 10,000. Okay, so what it's doing is it's looking like this. All right. I mean, super zoomed. So I'm going to go back to my regular zoom. Zoom standard 6. Okay. So what's the domain and range? Well, it's going to be all real numbers for the domain. So which one is all real numbers? There's only one with all real numbers. What is it? Yes. C. All real numbers. Given the function x squared minus 3, the domain is restricted to between 0 and 3. What is the range? Okay. Oh, okay. So what they're doing, we need to put that in our calculator. X squared minus 3. And I'm going to graph it. Okay, so they're restricting the domain. So it's not all real numbers. They just want to know from 0 to 3, just that set. So from 0 to 3. Okay, it's from here to here. What is the domain? That's Y. Shoot. No, that's X's. Yeah. Okay, from here to here. What's the range? The range is -3 to like a +6, I guess. So its range is Y, so it's B. That one's dumb. Okay, 23, which mapping, there is a question like this. Which mapping best represents this function when replacement for x is 0, 1, and okay, so look, put this function in the calculator. There's gonna be one like this tomorrow, so make a note. Put this function in the calculator. This is the last one. We could do it. 2x squared plus 5x plus 3. And I'm going to graph it. Okay. So to find this, I need to go to the table. It's asking where x is -1, 0, and 3. So -1 is 0. Tells us that in our table. -1 is 0. So which one says -1, 0? Well, B does. I think B might be at 0, 3, and 3, 36. It's B. And you can look at the table to match this. Okay? All right, good timing.